Hello everyone, and welcome back to the channel. Have you ever looked up at the night sky and wondered about those tiny moving stars? Those are satellites, our eyes and ears in the cosmos. But how did they get there? Today, we're going to embark on an incredible journey through time to uncover the story of how humanity placed its very first sentinels in space. Our story doesn't start with rockets and computers, but with a brilliant idea. Way back in 1687, Sir Isaac Newton, the same guy who figured out gravity, imagined a cannon on a very tall mountain. He reasoned that if you fired a cannonball fast enough, it wouldn't fall back to Earth, but would instead continuously fall around it. It would enter orbit. This was the seed of an idea that would take nearly 300 years to become a reality. For centuries, this concept remained pure theory, a dream for scientists and science fiction writers. Authors like Jules Verne and Arthur C. Clarke painted vivid pictures of a future connected by orbiting objects, inspiring generations of thinkers and engineers. But the real push came from a place of intense competition: the Cold War. The mid-20th century saw a fierce rivalry between the United States and the Soviet Union. Both superpowers saw the final frontier of space as the ultimate high ground, a new arena to demonstrate technological and ideological superiority. This race to the stars wasn't just about exploration. It was a matter of national prestige and security. The Soviet Union's rocket program, led by the brilliant but secretive chief designer, Sergei Korolev, was making incredible strides. Korolev, a man who had survived Stalin's gulags, was driven by a pure passion for space travel. He convinced Soviet leadership that launching a satellite before the Americans was a crucial goal. His team worked tirelessly, developing the powerful R-7 rocket, originally designed as an intercontinental ballistic missile, but repurposed for a loftier goal. On October 4, 1957, the world changed forever. From the Baikonur Cosmodrome in what is now Kazakhstan, Korolev's R-7 rocket roared to life, carrying a small, polished metal sphere. This sphere, just 23 inches in diameter and equipped with 4 long antennas, was Sputnik 1. Minutes later, as it circled the globe, Sputnik began to transmit a simple, rhythmic signal. Beep! 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 This faint pulse was heard by radio operators and amateur enthusiasts around the world. It was a message that transcended language. It announced that humanity had broken the bonds of Earth. A new era had begun. The launch of Sputnik sent shockwaves across the globe, especially in the United States. This event, known as the Sputnik Crisis, created a sense of urgency and even fear. How had they been beaten? The American public, used to being the world's technological leader, was stunned. This spurred a massive response. The U.S. government poured funding into science and technology education, and in 1958, a new agency was created with a clear mission: to lead America's civilian space efforts. That agency was NASA. The race was on. Just a few months later, on January 31, 1958, the United States successfully launched its first satellite, Explorer 1. Carried aboard a Juno I rocket developed by a team led by Wernher von Braun, Explorer 1 was much smaller than Sputnik, but it was packed with scientific instruments, and it made a monumental discovery. The data it sent back revealed the existence of intense radiation zones trapped by Earth's magnetic field. Today we know them as the Van Allen belts, named after Dr. James Van Allen, the scientist who designed the experiment. This discovery proved that satellites weren't just symbolic achievements. They were powerful tools for understanding our universe. The success of Sputnik and Explorer 1 opened the floodgates. The 1960s saw a rapid explosion in satellite technology. We launched the first weather satellite TIROS-1 in 1960, giving us our first ever view of cloud patterns from space and revolutionizing weather forecasting. Then came the age of communication. In 1962, Telstar 1 relayed the first live transatlantic television signals. For the first time, people on different continents could share an event in real time. Imagine the wonder of seeing a live broadcast from Europe in your American living room, or vice versa. This tiny satellite laid the groundwork for the globally connected world we live in today, where a video call across the planet is something we take for granted. Soon after, the first geostationary satellite, SYNCOM-3, was launched. Unlike earlier satellites that zipped across the sky, SYNCOM-3 was placed in an orbit where it moved at the same speed as the Earth's rotation. From the ground, it appeared to hang motionless in one spot, making it perfect for continuous communication. This was the blueprint for the vast networks of communication satellites that now power our internet, television, and phone calls. And we can't forget about navigation. The transit system, developed by the U.S. Navy, was the precursor to the Global Positioning System, or GPS. Initially for military use, it proved that satellites could be used to pinpoint a location on Earth with incredible accuracy. Today, GPS is in our phones, our cars, and our watches, guiding us through cities and across wilderness. It's a technology that began as a military project and has since become an indispensable part of civilian life. From those first simple beeps of Sputnik, the evolution of satellites has been breathtaking. They've become smaller, more powerful, and more specialized. We now have Earth observation satellites like Landsat, which have been monitoring our planet's changing forests, ice caps, and coastlines for decades, providing crucial data for understanding climate change. We have powerful space telescopes like Hubble and the James Webb, which are essentially giant satellites designed to look outwards, peering back to the dawn of time and capturing jaw-dropping images of distant galaxies and nebulae. They are our windows to the cosmos, expanding our understanding of the universe and our place within it. And now, we're in the era of mega constellations. Companies like SpaceX, with its Starlink system, are launching thousands of small satellites to create a global network aimed at providing high-speed internet to every corner of the planet. What started as a single polished sphere has become a vast, interconnected web of technology enveloping our world. So, from a thought experiment by Isaac Newton, fueled by the fires of a global rivalry and realized by the genius of engineers like Korolev and von Braun, the satellite was born. It began as a symbol of power, became a tool of science, and has transformed into an essential utility that underpins our modern civilization. The next time you use your phone to navigate, check the weather forecast, or watch a live event from halfway around the world, take a moment to think about that incredible journey. It's a story of human curiosity, competition, and ingenuity. A story that's written in the stars by those tiny blinking lights moving silently across the night sky. Thank you so much for joining me on this journey today. If you found this story as fascinating as I do, please hit that like button and consider subscribing for more deep dives into the wonders of science and technology. Let me know in the comments what satellite technology amazes you the most. Until next time, stay curious